Hello everyone, myself Vinay Kumar. I am pursuing PhD in physics. So in this particular YouTube channel, I'll be teaching physics, chemistry and mathematics starting from 8th standard till 12th standard. So if you want to learn physics, chemistry and mathematics, then please do subscribe to my channel. In my previous video, I was actually discussing the 7th chapter of 9th standard science subject that was on motion. So there is one more concept in this particular chapter which I will be covering in this particular video. So the last concept which I wanted to discuss in this particular chapter is uniform circular motion. First we have to understand what do we mean by circular motion. So by now you know what is motion, and we also know various parameters which are connected to this particular word motion. So now let us try to understand what you mean by circular motion. So for example, before going into circular motion, let's say there is an athlete. So if we imagine this person as an athlete, so this person has to run on a rectangular track. So let us imagine there is a rectangular track like this, and this person has to run on this particular rectangular track. So let's say the starting and the ending position is at this particular position. So from here, this athlete starts running. So for example, if he starts at this particular position, let's say this is the position O. So from this position, if he starts running, so initially he will run in this particular direction. So initially he will be running in this particular direction, but as soon as he reaches this particular position, if we keep following the same direction, then he cannot trace that particular rectangular path. So he has to change his direction at that particular position. So here at this particular point, this athlete has to change his direction. So he has to change his direction and again follow a particular straight direction. So again at this particular point, this athlete has to again change his direction, and again he has to follow a straight direction. So after that, at this particular point also, he has to change his direction and again he has to run straight. So after that, when he reaches this particular position, here also he has to change his direction and again he has to run straight and reach this particular position. That means in order to remain on this particular rectangular track, 4 times he has to change his direction. So only when he changes his direction 4 times, whenever is necessary, then only he can actually run on that particular rectangular track. So if he follows single direction, then he cannot remain on that particular rectangular path. So in order to remain on that particular rectangular path, he has to change his direction every required positions. So here at 4 different positions, he has to change his direction in order to remain on this particular rectangular track. So now we will remember this much. So we will consider one more example where let's say path is in hexagonal shape. So let us assume this is a running path or a running track. So this particular track is in hexagonal shape, and let's assume the starting and ending point are there at this particular position. So now if athlete starts running from this particular position, here he has to run straight and then he has to change his direction at this particular position. So again he has to run straight along this particular path, and again he has to change his direction at this particular point, and again he has to run straight on this path, and again at this particular position he has to change his direction, and again he has to run, and again he has to change his direction, and again he has to run, and again he has to change his direction. Now again he has to run, and again he has to change his direction at this particular position and reach the initial point. So in order to remain on this particular hexagonal running track, this particular athlete has to change his direction at necessary points 6 times. So there are 6 different positions on this particular path where he has to change his direction at that particular position so that he can remain on that hexagonal path. So here number of sides of hexagon is 6. So that's why whenever he reaches that intersecting point of 2 different lines of a hexagon, there he has to change his direction in order to remain on the track. So similarly, if I consider one more track which is in octagon shape, so let's say this is an octagon, and let's say this is an octagon shaped running track. Here if an athlete is running on this particular path, he will be changing his direction at 8 different positions. So 1, 2, 3, 4, 5, 6, 7, 8. At 8 different positions he has to change his direction. So 8 times he has to change his direction. So whatever 6 and 8 I am writing here is change in direction. So here this particular athlete has to change his direction that many times depending upon the shape of that particular track. So now let's say I will go on increasing the number of sides. So initially I took rectangular shaped, and next I took hexagon shaped track, and next I took octagon shaped track. So now I will go on increasing the number of sides. So let's say I'll take 100 sided track, or let's say I'll take 1000 sided track. So like this, if I go on increasing the number of sides, so I'll increase infinitely the number of sides. So when I increase the number of sides infinitely, then this particular shape will approach a circular form. So you will end up in a circular shaped running track. So on this particular circular shaped running track, so in order to remain on this particular circular path, that athlete has to change its direction on every single point. So every single point on this particular circle acts as side. So I have increased sides to infinity. So that means every single point is a side, and every single point is a change in direction for that particular athlete. Then he has to change his direction at every instant, at every point on this particular running track. So now this is a circular shaped running track. The shape of this particular running track is circular, and the change in direction is with respect to the radius of that particular circular path. So if this is a circular path, then this particular radius will be there for this particular track. So let's say there is radius r. So every point when they take change in direction, every point when they are changing their direction, at that particular position, they have to maintain that radius r with respect to the center of that circular shaped track. So that means here constant and same amount of change in direction is happening at every point on this particular circular path in order to remain on that particular circular path. So they are constantly in motion, and also constantly they are changing direction in order to remain on that particular circular path. So here this kind of motion of a particular athlete or an object can be known as circular motion, because if they are running on this track means they are already in motion, but they are constantly changing their direction, and same amount of change in direction they are actually doing in every point on that particular circular path in order to maintain that radius r with respect to the center of the circular track. So that's why this kind of motion can be known as circular motion. So now let us say there is a path, there is a circular path, and let's assume that this is the center of this particular circle. So this circle will be having radius r, and an object or a car is moving on this particular circular path like this. So let's imagine this object is moving on this particular circular path. So here basically this particular car or a vehicle or an object is covering the circumference of this particular circle. Here you can see this particular circle has its own circumference. So here this object is covering this particular circumference. That means here the distance traveled by this particular object or a car or a vehicle is the circumference of that particular circle. So now if we want to calculate the speed of this particular circular motion or uniform circular motion of this particular object, then we have to take the total distance divided by the total time taken to cover that particular total distance. So total distance divided by total time. So what is the total distance? So total distance is the circumference of the circle, because this particular object or a person or a vehicle is covering the circular path on the circumference of that particular circular path. So that means there is a circle, they are tracing the circumference of that particular circle. So that's why total distance will be equal to the circumference of that particular circle. So what is the circumference formula? Circumference formula is 2 pi r. So that means they are covering 2 pi r distance, and they are taking certain amount of time t. So 2 pi r by t is the formula to calculate speed of a particular object or a vehicle which is traveling in a uniform circular motion on a circular path. So basically you should remember that if any object or a person is traveling on a circular path with uniform speed, then that particular object or a person is said to have uniform circular motion. So now when I was explaining circular motion, I mentioned that on a circular path, a particular object or a person has to constantly change their direction at every point on that particular circular path. So now I'll give one example where we can understand how a particular object or a person who is traveling on a circular path will be constantly changing his direction on that particular path at every position on that particular path. So now there is a person who is actually having a thread tied to a stone. So now this particular person is revolving this particular stone around him like this. So he is giving a necessary amount of circular motion to that particular stone, and that stone is tracing a circular path around him. So now if this particular person releases the thread, then the stone which will be traveling in that particular circular path will no more travel on that particular circular path. Rather, it will follow a tangential path for this particular circular path. So now here you can notice that a particular stone which was actually traveling in a circular path has suddenly changed its direction and it started moving straight. So that means it has started moving tangentially to that particular circular path. It is now following a straight path after releasing that particular stone. Why this has happened? So now in order to understand this, when he was holding that thread, he was giving the necessary amount of centripetal force, which you will be learning in your higher classes, for that stone in order to change its direction at every instant, at every position on that particular circular path. So that means if a particular object is traveling in a circular path, so let's say this is a circular path and an object or a stone is traveling in this particular circular path. In order to this object or a stone to change its direction at every instant of points on this particular circular path, necessary amount of force is required. Just like that, any object cannot change its direction, because in order to change its direction, even an athlete while running on a circular path, in order to change his direction every point on that particular circular path, he has to apply certain amount of force within him to change the direction. Similarly, if a stone is traveling on a circular path, every instant on that particular circular path, that stone should get certain amount of force in order to change the direction to remain on that particular circular path. That means here, when that person was holding that thread and he was rotating or revolving that stone around him, so at that particular point he was giving certain amount of centripetal force which is required to change in direction for that particular stone at every point on that particular circular path. So now when this particular person has released that particular stone, he has stopped giving force required to change the direction of that particular stone. So immediately when he stopped giving that particular force, that means immediately when he released the stone, so that instant, whatever the direction it was following at that particular position when he released the stone, so in the same direction it starts moving. So for example, if this is a circular path, here at this particular position, object will be in this particular direction. So at this particular position, object will be in this particular direction. At this particular position, object will be in this particular direction, and at this particular position, object will be moving at this particular direction. So that means that change in direction is there at every instant on that particular circular path. So when the force is not supplied to change its direction, so let's say object has reached at this particular position, and in this particular position it is traveling in this particular direction. So suddenly that change in direction is not happening because the object was released, the stone was released. So that's why whatever direction it was following at this particular position, the same direction it follows and it goes like this. So that's why whenever that stone is released from a person, at that particular point he has stopped giving the necessary amount of centripetal force. You will be learning what do you mean by centripetal force in your higher classes. So when he stopped giving that particular centripetal force, necessary centripetal force for that stone to change its direction, whatever direction it was following at that particular position when he released, so the same direction it starts moving. So that will follow a tangential direction which it was following at that particular position with respect to that particular circular path. So that's why when this particular person leaves that particular stone or releases that particular stone, it follows a tangential path for that particular circular path from that particular position where it was released. So with this, I am completing this particular 7th chapter of 9th standard science subject. So the exercise questions which are there in this particular chapter, I'll be discussing that in my subsequent videos. So till then, if you want to learn more physics, chemistry and mathematics, then you have to subscribe to my channel. Please do subscribe to my channel and stay tuned with my channel. Thank you.